Well, hello everybody. Guess we'll get started here. My name's Derek Groth. I'm with MP Next Level, part of the ICA committee here as well. I'm just going to introduce you real quick here. Sergiu Albu, he's from Cleveland, Ohio. He's with Cambium Networks. He's been in the industry for 15 years. He's wild, he's crazy. Let's give him a little warm welcome here. All right.
Thank you. I appreciate that. I am definitely very crazy, especially after that walk from my hotel. It was freezing. Yesterday was so nice, and today, terrible. But kind of like Cleveland, Ohio anyway, so I'm used to it. Well, I appreciate you guys taking the time and coming into this session. Just a quick show of hands. How many of you guys today do any kind of wireless technology? Okay, so a few. So what I want to do today is I kind of just want to show you guys what's going on in the industry. 2024 is a big year, right? Everybody knows about the BEAD funding. Everybody's waiting for a ton of money. How does the wireless, fit into all of this? I think you guys will have a really good idea after, a quick half-an-hour presentation. I'll leave some time at the end for questions, and I'll be here all day. I do have my cards on me, so if you guys want to take it, after the session and have a conversation, have a sit down, feel free. I do have today available to sit down and to chat with you guys. So anyway, so what's going on in the wireless industry? Huge win on the spectrum side. So the FCC, after about 4 years of trying to free up some spectrum for the wireless manufacturers, they have actually released 6 gigahertz. This happened a couple of weeks ago. It's a huge milestone for the whole industry. You could do a lot of things if you have spectrum. If you don't have spectrum, which the FCC kind of hugs a lot and doesn't really release it, you can't really do high capacity. So now, because of 6 gigahertz, it's a ton of spectrum that was released. Now we can do the gigabit speeds over 2, 3, 4 miles and so on. So, and we'll kind of cover that. We'll talk about a little bit about the spectrum and then the gear that's available today. Okay, so what's going on? So the FCC during COVID 2020 kind of caught everybody off guard, right? Everybody had to work from home. There wasn't enough connectivity, not enough throughput, especially in the very rural areas. And they came to the wireless WISPs and integrators and said, hey, how can we set up networks? And we said, we can do it right away. The problem is you don't give us enough spectrum to do any kind of substantial throughput. So if you're looking, to offer the gigabit services, we're going to need more spectrum. So they started about 4 years ago. 4 years later, which is like the FCC moves very fast. Kidding, but they released 1.2 gigahertz of spectrum. And 850 of that, it's actually for broadband service only. Again, huge win. Before, everybody operated in 5 gigahertz. 6 gigahertz is very similar to 5 gigahertz. And the fact that, we have almost double the spectrum that we had in 5 gigahertz, it's a huge win for the industry. So like I said, 1.2 gigahertz of spectrum, 850 is for outdoor use, the other 350 is for indoor use, lower power, so for Wi-Fi devices. So what did we have until now? We had 5 gigahertz, and everybody worked it and used it and overused it and a ton of interference, but that was your only option at the time. During COVID, the FCC released another 45 megahertz of spectrum at the end of that 6 gigahertz spectrum, which actually helped quite a bit, relieved a lot of networks, so it was definitely a positive for the industry. But then, like I mentioned 2 weeks ago, is when the real big winner was, and when we released the 6 gigahertz spectrum. And what's amazing about it is that you can actually operate at fairly high output power. So the EIRP is 36 dBm, which in 5 gigahertz, you only had about 250 megahertz of that spectrum. So now you have about 850 that you could use at much higher power. So again, like I mentioned, we'll talk about the products, but you can actually go long distances offering very high capacity. What took so long? So the carriers complained about it. So 6 gigahertz, it's usually a licensed microwave band, point-to-point shots between towers. And the carrier said, look, if you're going to allow these people to start operating in an unlicensed band, which is taken by us as a licensed point-to-point microwave, they're going to interfere with us. So the FCC said, that's fine. We'll create a database, and we'll make sure that everybody that uses 6 gigahertz, they stay away from the licensed links that are available, that are coordinated in your particular area. So what it really is just a database. For example, Cambium Networks manufactures 6 gigahertz radios. The way we do it is if you're trying to operate in an area, we have the database loaded in our network management software, and it won't allow you to use that particular channel if there's licensed microwave available on there. And I'm sure a lot of the manufacturers that are gonna have 6 gigahertz product are gonna do the same exact thing. So what we wanna do is we wanna make sure we don't upset the big giant carriers, so they can let us operate and use the band as it is available. But expect the band to be available, especially in rural areas. Like, obviously Iowa is pretty rural with a lot of telephone companies and a lot of wireless internet service providers. Expect to find a ton of that 850 megahertz spectrum. So that shouldn't be an issue at all for you to be, for you to be able to find some spectrum and to operate. And the AFC is live today. Like I mentioned a couple of weeks ago, the FCC released, the spectrum. They said we're ready to go. Deploy at your own will. The only thing we're really waiting on now is we're waiting for the products to be FCC approved, right? So in order for you, so you can't really approve something if the band is not available. But now that the band is available, we got to wait a little longer until everything gets approved. But we expect everything probably by the end of this week, end of next week. Most manufacturers that are gonna have 6 gigahertz product, they'll be FCC approved, so you can start deploying. By the time you buy it this week, next week you get it, you should be all good to go. Now the hardware trend. So we talked about the spectrum, right? Good idea to release a lot of spectrum, but it's no use if you don't have any gear to use with the spectrum. What does some of the gear that's out there capable of doing? So a lot of backwards and forwards compatibility. So if you're a manufacturer and you had 5 gigahertz products, now these products also support 6 gigahertz. So if you have subscriber modules deployed out there, you can kind of do a backwards compatibility, so you can swap out the access point. You can still use it with your 5 gigahertz subscribers and operate into 6 gigahertz as well, to use more bandwidth and to offer higher packages. A lot of much larger channels that we were used to in 5 gigahertz. So 5 gigahertz, we didn't have much spectrum. If you could use a 20, a 30, maybe a 40 megahertz channel was a win. Now you're talking about 850 megahertz of greenfield spectrum. You could definitely use 100 to 160 megahertz channels is actually the highest that any products on the market do. No problem offering gigabit speeds at 2, 3, 4 miles away from that tower. So again, just a different level of service offering. Carrier aggregation. So as chipsets advance and as, just like technology, the TV you bought 3 years ago is not as performant as the one you go to Best Buy to buy today, right? It's just how technology works. So just everything much faster, much better, longer distances. So it allows you to offer service that you were never able to do, a year or two before. Much higher modulation, allowing you to do higher throughputs. Multi-user MIMO, so these radios are capable of combining subscribers and communicating with them at the same time. So the more subscribers you add, the more you actually increase the capacity in that particular radio. You're being very spectral efficient with N=1 frequency reuse. So if you're deploying 3, 4 sectors to cover 360 degrees around the tower, now all you need is just one frequency band. So a lot of technology that allows you to do things that you were not able to do in the past. And also now these radios are capable of operating in very noisy environments. So even if you have another operator in the area using the band that you're using, the radio is capable of to jump around and bounce around and still continue to connect subscribers and offer high throughput. Now that was for chipsets that are, proprietary to different technologies. Now let's talk about, just 802.11 chipsets, which is, chipsets that are available there. You can buy. This is usually on the lower cost platforms. So what happens is, these chipset manufacturers make these chipsets. they put certain features on it, and there's really not much you could do to enable other features. However, this new 802.11ax chipset, standards-based chipset, is by far the best that this industry has ever seen. And why is that? Much higher throughput, much higher modulation codes. It's capable of doing, higher multi-user MIMO. It's, downlink and uplink multi-user MIMO. So it can operate at very, very high capacity on different channel sizes. It's capable of operating really well in interference. It's capable of using larger channels, and now with spectrum available, you are actually able to use larger channels. So everything about this chipset has been great, and a few manufacturers have actually developed radios that operate using this chipset, and it's taken it to a definitely different level, and I'll show some case studies here in a little bit. What do these radios do again? For each access point, up to 4 gigabits of capacity. Before, you were lucky if you were getting 300 to 500 megabits out of an access point. Now you're talking about 7, 8 times that. Much higher multi-user MIMO, so it's capable of combining multiple subscribers and communicating with them at the same time, allowing you to do much higher throughputs in a single network. The more subscribers you add, the higher the throughput in that access point. It's scalable, and it can work really well in interference. This is huge because eventually, even if this is greenfield spectrum, eventually the spectrum is going to get used up. But because you're able to operate in noisier environments, it allows you, to feel free, to feel secure that you're deploying something today, and even if your neighbor is coming and putting something up in the future, you can still operate, with interference present. You could do up to 120 clients an access point. You're never going to get there probably, but at least you know that you can always add more subscribers, and that's not going to be a limitation or an issue to to what you're trying to do. GPS synchronization, you're eliminating self-interference, which is huge, right? The more spectrum you use, the more you start causing noise out there. Sometimes your biggest harmer is yourself. So GPS sync allows everybody to actually talk and kind of have everything in order in a particular network. And low-cost products allow you to make money much faster, right? That's why a lot of you guys are in business. That's why a lot of operators choose to buy these radios, because your ROI could be 6 months to 12 months as opposed to 24, 36, or 48 months, which could take a long time. By the time you pay it off, technology is actually old, and you need to you need to look at the next upgrade. So all of these things are extremely important, and a huge advantage at the low cost price point. And now just the real deal. This is probably the most important slide that I want to show you guys. It's, look, now you could go half a mile, a third of a mile, and do the gigabit packages, right? As you can see, some of these sites, half a mile getting almost 2.5 gig of capacity aggregate. It's pretty amazing. Something in wireless you were never able to do, other than really short ranges. In some of the higher frequencies. So this, for the wireless industry, is a game changer, right? Everybody's talking about the BEAD funding. BEAD funding wants to connect everybody at gigabit speeds. How do you do gigabit speeds other than doing fiber? Well, now you could do it with wireless, which is, again, for us, it's a huge game changer. You could even go further than that, 1.5 miles, 2 miles, and look at the capacity you're getting, 1.5 gigs or 2 gig. Again, something that we've never seen in the wireless industry. Before, if you're able to do 100 by 20, was a win-win situation. Now, you could do gigabit speeds at longer distances, which will take the wireless industry to the next level, next step. And now you don't just have to think we have to deploy fiber if we want to do gigabit speeds. Now you could think doing it with wireless technology. 5 gigahertz. What these chipsets before used to be strictly line of sight. The reason why I wanted to include this, now line of sight is no longer a requirement. You could do near and no line of sight in some cases. There's a lot of heat maps and services like that that you could actually do before you deploy gear, and you could see what kind of results you should expect. Again, no line of sight. It was an underthought, especially in 5 and 6 gigahertz now. Today, you could do that. You could feel secure and safe to deploy things in near line of sight, no line of sight, foliage, hills, and still get capacity and get a customer connected, where you need to. So again, the chipsets and the products have made it a long, long way from where they used to be. This, I apologize, you probably can't see it really well. This shows, an access point with 47 subscriber modules that is offering, 100 meg packages, 100 by 20, to multiple subscribers in one sector. So the things you're able to do today, with the BEAD funding around, everybody's asking for 100 by 20. You're capable of doing that at no issues on multiple subscriber modules off of one access point. Now, speaking about the BEAD funding, so as you guys very well know, I'm not sure if you're trying to play defense, if you're trying to play offense, but obviously the federal government said, if you're not offering 100 by 20 packages in most states with either fiber or licensed technology, then you are considered unserved. If you are offering 25 by 3 or by 5 on fiber or wireless licensed spectrum, then you're considered underserved. If you're offering 100 by 20 on licensed or fiber, then you're considered served. So a lot of people said, okay, that's fine. The CBRS spectrum became available in 2020, right around COVID. And it's half of it is unlicensed, half of it is licensed. So a lot of the carriers or a lot of the service providers said, well, look, I actually combined some of the unlicensed and some of the licensed spectrum together. So can you please allow me to use both? So the FCC said, you know what? That's great. All of 5 gigahertz, all of 3 gigahertz, 150 megahertz of spectrum, it's all considered licensed now. So how does CBRS work? So CBRS, it's a paid service. It's a monthly paid service, so you have to have a SaaS provider. What that means is that if you're operating the band, you have to pay the FCC a fee every month. $3 per subscriber is what Cambium Networks charges in order to police the band, so to speak. There's a couple of providers, there's Federated Wireless and Google, that are the SaaS providers. It's pretty much a licensed spectrum, and it allows you to operate and to be, if you're offering 100 by 20, then you are covered under the FCC rules for the BEAD funding. So it's extremely important. It's not much spectrum. That's why we want to make sure that we maximize the spectrum that we are using in 3 gigahertz, but it allows you to be covered, and it doesn't allow other people to come and overbuild you if you are capable of offering 100 by 20 in the 3 gigahertz spectrum. So again, it's extremely, extremely important. If you're trying to play defense and make sure that no one comes into your territory and overbuilds you, if you're offering 3 gigahertz service to your subscribers, then you are considered served and free from any type of overbuild. So that's why I wanted to include that. CBRS has been around for a while. A lot of people have been deploying it, but it's extremely important to make sure that you guys are aware and that you know that securing the spectrum and operating in it allows you to keep other competitors from coming into your region with the BEAD funding. 60 gigahertz, this is the last band I'm going to cover. Why 60 gigahertz is important is because there's a ton of spectrum available. Now, the limitations with 60 gigahertz is, so like I mentioned, it's a ton of spectrum. In the US, 6 different channels. So you have about, you have over 12 gigahertz of spectrum available. So you could use big chunks. The problem is, it doesn't travel very far. and it's a line of sight a product. So any 60 gigahertz products, they have a very, very tight beam width. So you have to make sure that there's, the radios can see each other and you're not stretching them out too far. Oxygen absorption actually causes the link to drop. So again, very close and line of sight. But you could offer 2, 3, 4 gigabits to each subscriber, as you're deploying in a wireless network. Why 60 gigahertz is awesome, it's because it's unlicensed spectrum. So you don't have to pay anything, you don't have to apply for anything, you can just use it. Interference is not an issue because it doesn't travel very far, so you're never gonna get a ton of noise. And it allows you to do extremely, extremely high capacity over very, very short distances. Again, it's, smart cities, you see it a lot when you go in downtown areas of larger cities, probably Des Moines, camera systems, Wi-Fi in parks, things like that. You could backhaul and you could use a lot of this technology, to support a lot of customers on, like I mentioned, either Wi-Fi, cameras, or, a replacement for fiber to home. We're starting to see these products be extremely popular in, neighborhoods where people say, hey, I don't know what my take rate would be if I was gonna deploy fiber here. So let me throw up some access points, let me see, what my take rate would be. And then, they get a handful of customers and they see, hey, well, why would I even, build the fiber here? It works great on the wireless, so, I'll just continue deploying that. Or sometimes people build fiber, they'll leave it as redundancy. So again, it just gives you another dimension of building a good, reliable network overall. Kind of show you, so why it's important, these new radios, they actually support mesh. So because it's such short distances, sometimes if you have a tree in the way or if you have some kind of an obstruction, then you couldn't really offer service. But because these radios support meshing, now you can get around obstructions and around trees and around hills and things like that. So it's, it just gives you a new, different dimension of building a wireless network. So not only does it support point-to-point and point-to-multipoint, it also supports meshing. And this kind of gives you an idea of, the closer subscribers, you have an access point. We call them distribution nodes in the mesh world in 60 gigahertz. So you have a distribution node and you connect it to customer nodes or CNs. And it depends, how far. It's a different type of antenna gain, in order to be able to make that connection. So, the smaller radios have a lower antenna gain. The larger radios have a higher antenna gain in order to be able to connect things, half a mile, 3/4 of a mile, and so on and so forth. And that's exactly what this shows you. And with the fact that you can actually do meshing, build these networks, it actually helps a ton, in these neighborhoods where you have trees present, where you have a lot of obstructions, so on and so forth. So, like I'll show a few examples of how quickly you can deploy a network and how quickly you can get around trees and do things like that. So this keeps building up. So again, gigabit speeds in 21 days. I mean, we all know a lot of you guys do a ton of fiber. This is, you can't even, try to do the engineering on a network in 21 days, right? 21 days, you can actually deploy a full network. It's pretty amazing. And as you can see to the right in the schematic, you use point-to-point, you use point-to-multipoint, you use meshing. So the versatility that this gives you, as long as you can keep it within close distances, you could offer service for 2, 3, 4 gigabits of throughput. A lot of people don't even know that this is available out there. So, wanted to make sure that you guys understand that 60 gigahertz is extremely, extremely efficient, and it, you can build a network, like in this case, 3 weeks, and you're offering gigabit speeds, which is pretty amazing. Again, and the smart city type of deployments. You can put a couple of distribution nodes, you can have a couple of customer nodes, and just deploy and offer gigabit speeds to cameras, to homes, to buildings. We see a lot of this that, especially during COVID, when things had to happen quick, You put one of these backhauls, a building that's unserved now has gigabit speeds. You're capable of doing Wi-Fi inside of it and connect the customers, and they can do work from home and do school from home and so on and so forth. COVID opened up a lot of these avenues that people didn't even think about, and people didn't really realize how underserved we are, in the U.S. market. So again, it's just another way to do things and to do things at very, very high capacity. Comparing it to fiber, this shows you a great example of you have a small little community, they're unconnected, you can bring in from a nearby tower that has fiber with a point-to-point link, you can bring high capacity, and then you could build a mesh or a point-to-multipoint network. Fiber probably would have cost you somewhere in the area of $150,000 to deploy it, and probably would take half a year to a year at a minimum. You do it for $15,000, with the wireless technology, and it probably will take you a few weeks to a month maximum. So the ability to build quick, fast networks, it's pretty amazing with with this wireless technology. So again, between 6 gigahertz going over long distances, doing gigabit speeds. CBRS protecting you on beat and allowing you to do it at a minimum 100 by 20 megabits packages. 60 gigahertz, keeping it close and being able to do anywhere, from 2, 3, 4 gigabits to a single subscriber. Those are all ways to offer high capacity at a fraction of the cost and at a quick deployment. So again, extremely, extremely important to think about it. And if you guys, a lot of you guys are fiber companies, that's great. Once you put it in the ground, it's there forever. But just know that sometimes to get, the last mile customers, or to connect, a few guys in an area where you'd never get your ROI with fiber, this is a valuable way to do it with some of the unlicensed or licensed frequencies, in the wireless world. Again, wanted to make sure that you guys know that this is available, know that there's a lot of companies, a lot of manufacturers like Cambium Networks that can help you with the engineering. There's a lot of partners that can actually help you design and build your network and do everything turnkey. So just know that a quick, easy way to do it is to use wireless technology. So I know a ton of you guys, I sit in meetings all the time and people said, oh, I tried this 10 years ago and it never worked and I'm never gonna try it again, it was stupid. Don't think like that anymore. The technology has made it so far, it's so advanced. It's actually kind of crazy how these standards-based chipsets now can offer this high capacity at a fraction of the cost. Even if your end goal is to build fiber, that's fine. But just know that you can start getting revenue within the first month of deploying some of these radios, as opposed to waiting half a year or a year to deploy a fiber network. So some of the things to keep in mind for you guys as you're building your network and as you're protecting yourself from BEAD, you want to make sure that a lot of those service providers that come from different states and apply to anywhere they see the capability of building a network, and they'll come right in your backyard and overbuild you. So that's really, really all I had. It's actually good on timing. I wanted to leave about 10 minutes. If you guys have any questions, I know there's a lot of data, a lot of stuff that I went through. Again, I'll be more than glad to sit down with you guys if you have additional questions. I know some of you guys are already deploying these networks. Just know that you are able to do, build a good network with high capacity at a fraction of the cost that you're actually used to today. Any questions? Somebody's got to have a question. Come on. No? Covered it all? Yes, go ahead.
6 gig lightly licensed, how does the process work on that?
Great question. So actually, to deploy 6 gigahertz doesn't cost anything. It's about, I believe, and don't quote me on this, I think it's $10 for 7 years, I think I heard. So we don't charge, as a manufacturer, Cambium Networks, we don't charge you anything. It's not like CBRS where it's $3 a month per device. We include it in the cost of the radio. And what you have to do is you have to make sure that you connect the radio to the AFC. So if anything you deploy has to have a GPS module in it, so the FCC knows where that radio is at all times, and you have to and you operate it. Our own NMS is enough as long as you're using our NMS, which is free. It doesn't cost anything. You're able to deploy in 6 gigahertz. So there's no cost. There's nothing. So it's not really lightly licensed. I would say it's unlicensed, but you do have to let the FCC know where you're deploying the radios. That was their request. Again, to protect the incumbents, the point-to-point licensed microwave from the carriers. It was the big AT&T and Verizon that threw a fit, and they said, hey, look, you can't allow all these wireless internet service providers to deploy 6 gigahertz. They're going to step all over everybody. They're not going to care about anything, and they're going to, it's going to be a wild, wild west out there. So that's why the FCC said that's fine. We'll come up with the AFC. So when you use our radios, let's say you deploy Cambium radios today. Let's say you deploy it in Des Moines. If there's a licensed point-to-point link in the area that you're deploying the radio, it will actually, the interface won't allow you to pick that channel because the database is already loaded. It knows what spectrum is taken by a licensed microwave link. So it won't allow you to actually operate in that particular channel. Now, you have to remember, the largest channel you could do in a point-to-point licensed microwave in 6 gigahertz is 60 megahertz. 60 megahertz, I don't even care if there's 2, 3, 4 licensed links in the area. You have 850 megahertz of spectrum available. You're gonna be able to, to find an open channel, 80 megahertz, 160 megahertz. It should not be an issue. And as the band gets more filled up, the fact that the radios do interference mitigation helps you deploy and sleep good at night, that even if there will be interference later on, you'll still be able to operate. And not to mention that if your neighbor wants to operate in 6 gigahertz, but you've already taken all the spectrum, they're going to see interference too. So they don't want to deploy in something that's already been taken. So keep that in mind as well. Any other questions? Yes, go ahead. Okay, so let me go backwards and tell you about 5 gigahertz. In 5 gigahertz, there's about 650 megahertz of spectrum. And service providers have been making that work for 15 plus years, right? So now you're talking about 850 megahertz. So you're talking about a third more and, greenfield spectrum. So to answer your question, and with the products being able to operate in noisy environments, so even if there's somebody else operating, you can actually bounce around the signal and figure out ways to work a radio. I think you're going to be golden for a really, really long time. And not to mention, sure, if you're downtown Chicago or downtown New York, yeah, it's going to get full. It's going to get full quick. These people are going to start using the spectrum. But if you're in, Dubuque, Iowa, I'll be honest with you, I'll put my money that you'll be good to operate for a really, really long time. And again, these radios are capable of doing larger channels, which sure, it's going to get you there quicker. But still, with the interference mitigation, I feel extremely safe. Again, you guys have figured out a way to deploy 5 gigahertz for so long with much, much worse technology. I don't foresee this being an issue at all anytime soon. And you know what's going to happen when the FCC decides that, hey, look at what 6 gigahertz has done, right? It's amazing. We can deploy, gigabit speeds over 2, 3, 4 miles, which we were never able to do before. Maybe we can give them 4 gigahertz. Maybe we can give them 7 gigahertz, and then continue building on that. So I think this is a step in the right direction, and I think service providers like yourselves actually, I think the reason why we got to 6 gigahertz is how quickly WISPs were capable of deploying networks during COVID. COVID was a crazy time, right? Everybody had to all of a sudden be locked in their house, and they still had to be connected. You can't build fiber that quickly, right? I can certainly promise you that a ton of my customers that I sell radios to, They build these networks overnight. You know, it was weeks as opposed to years or months. So I think the FCC realized that, man, so these guys, we can hear them out and say that if we give them more spectrum, they can actually do things that fiber can do. Sure, wireless will never be fiber, I get that. But it's a quick way to deploy a network and to do extremely, extremely high capacity. Hybrid networks are here now. Like, if you're not building a hybrid network, you're probably wasting a lot of money in some areas. You probably know that fiber doesn't make sense, but you have to do it, you know, because you're a co-op and you have to tend to all your customers. You could do that with building a wireless network at a fraction of the cost. Why not? Sure, it's a new learning curve, but it's something that, you know, manufacturers like Cambium or, you know, other integrators can help you build and can give you confidence that, you know, you can build a really, really good network and you know, offer high capacity, which before you weren't able to do unless you did do fiber. Any other questions? Anybody else? Okay, well, like I mentioned, I'll be around. I have some cards if you guys, you know, would like to continue the conversation. There's, you know, a few of you guys in here that I know have deployed networks. And if you have any questions about, you know, what's going on in the industry, what, you know, what's, you know, what the roadmap looks like, you know, what BEAD funding needs to, you know, what you need to do in order to protect yourself or to be aggressive, to go get some, you know, let me know. Like I mentioned, I'll be around today all day. And again, I appreciate your guys' attention and thank you very much for coming here. And thank you to the ICA for putting this great event together. I appreciate it.